Another question of HCV and HOTS series. Outer cylinders of two capacitors of capacitance 2.2 microfarad each are kept in contact, and the inner cylinders are connected by the wire, like that. This is the diagram, and a battery of 10 volt is connected. Find the total charge supplied by the battery to the inner cylinder, like that. Here the 10 volt battery is there, and this is the way. Here outer connection, and inner one is given the two parts. Both are parallel. So how to solve? We know it is given the cylinder is having the capacity 2.2 microfarad, and voltage potential difference is your 10 volt, right? So we know Q is equal to CV. So here 2.2 microfarad into 10 volt, that is around you will get the 22 microcoulomb, that much charge. So the total charge supplied or given to the inner cylinder will be 22 plus 22 microcoulomb, that is 44 microcoulomb. How it is 22 plus 22? Here it is supplying the 22, and this is also these two are parallel connected. So whatever the charge is supplied to the inner one is the same as in case of the this one, inner one number 1, inner one number 2. So 22 plus 22, 44. That should be your answer. Another question. Find the equivalent capacitance of the system between A and B. A और B के बीच हमको क्या निकालना है? Equivalent capacitance. So what we are going to see it here. Here, these two, this and this, are in series, and the resultant of these two are in parallel with C3. Here also C1, C2 are in series, and the resultant of this C1, C2 are in parallel with this C3. So how to draw it? Again I am drawing the resultant. This is your A and B. This is C3 in between. Now this one is the resultant of C1, C2, which are in series, and then its value will be C1, C2 by C1 plus C2. Similarly, this one is a series or the resultant of C1, C2. This C1, C2. So this also C1, C2 by C1 plus C2. How it comes? 1 by C is equal to 1 by C1 plus 1 by C2. Take the LCM like that. And these three are in parallel. So the C equivalent will be, in case of the parallel, C1 plus C2 plus C3 होगा. So C1 means C3 plus this much C1 C2 by C1 plus C2 plus C1 C2 by C1 plus C2. So what we are seeing here, this same term is there twice. So we can write twice of C1 C2 by C1 plus C2 plus C3. That is your equivalent capacitance. Right? Another interesting question. A capacitor is made of a flat plate of area A and a second plate having a stair-like structure, CD. The width of each stair is small a and the height is b. the find the capacitance of this assembly. How to find the total or the equivalent capacitance. So what is the main thing? What we are going to see it here. This is the number one. You can say this plate is fixed and it's a 3A, the total, and this one capacitor. This is another capacitor. This is a third capacitor. 1, 2, and 3. So these three capacitors are connected in series. Three capacitors are in series. Now it is given A, this is your B, A, B, like that. So we know the general principle of finding the capacitance. You know the capacitance in between the parallel plate capacitor is your A epsilon naught by D. D is the separation between the plates. That is the general formula. Now in this first case, first capacitor, we have to do it like that. The C1 is equal to, now area becomes the area of total area is your A. If the total area is A, surface area, so all this individual is having the A by 3 area. So here epsilon naught area of that area becomes 1/3. It is given that this particular area is uniform area. It may be due to the thickness and the breadth and the length and the breadth. Area of this are uniform. Means the total is A, then first one is having the A by 3, second one A by 3, third one A by 3, like that. So epsilon naught into A by 3 for the first one we are finding. Epsilon naught into A by 3 by D. The separation between these two, this plate and this plate, is your D by D. So we can write it epsilon naught A by 3D. Right? Then comes the second one, C2. Epsilon naught area is A by 3 by separation between these two. ये दोनों प्लेट के बीच का एरिया, ये दोनों प्लेट, ये प्लेट एक्चुअली, ये कैपेसिटर एक्चुअली इस तरह का है, दिस एंड दिस वन, दिस इज द थर्ड वन, लाइक दैट. दिस इज द कैपेसिटर. सो बिटवीन दिस प्लेट एंड दिस प्लेट द डिस्टेंस इज योर D plus B, राइट or not? यहाँ से यहाँ तक D, this plus B, D plus B, that is your epsilon naught A by 3 B plus D or D plus B. Second one. And the third one, only we have to see the distance epsilon naught A by 3 by the separation between this plate and this place for the third one, that is your B, twice B plus D, twice B plus D, that is your epsilon naught A by 3 twice B plus D. This is for C1. These three are the capacitance of the first parallel plate, second parallel plate, third parallel plate capacitor. First, second, and third. Now, equivalent. After finding this equivalent, as these three are in parallel, not in series, are in parallel. Looks like, just to see, I am turning the page. This now, इस तरह का, this, इस तरह का parallel. माने इसका कनेक्शन ऐसे 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 ऐसा ऐसा प्लेट. So these three are in parallel, not in series, right? So in parallel. So if the parallel is there, C equivalent will be C1 plus C2 plus C3. If you are going to add it, just you add it and you will get it. After adding, we'll get C equivalent is equal to C1 plus C2 plus C3. Epsilon naught A, put the value and get common, and just you calculate 3D square plus 6BD plus 2B square. We have taken the common, 3D, B plus D and 2B plus D. That should be the value of the equivalent capacitance. Right? Remember, these three connections are in parallel. As I told you, this is the way. First we have find the C1, C2, C3. Then as these three are in parallel, so C equivalent will be C1 plus C2 plus C3, and we have find out in this way. Put the value and calculate, you will get that expression of C equivalent.